Hello, my name is Canis. Uh, I want to appreciate you for staying tuned to my channel and also thank you for finding my channel worthy to subscribe to. I shall be discussing the taking off of reinforcement bars for isolated footings, the starter columns, and the column above ground up to first floor slab. Like I often tell my viewers that quantity surveyor needs Excel to reduce the time he spent in carrying out some certain works like measurement of quantities. If a surveyor knows how to use, a quantity surveyor knows how to use Excel, he's going to reduce the time he spent to do his job by 50%. 50%. And I am going to prove that my assertion is right with this illustration that I want to show us in this video. If as a quantity surveyor you have prepared formats of spreadsheet to aid your work, your measurement, what you need to do is just picking, say, 30 or 10% of what you ought to have picked when you were starting the whole job afresh. That's what you're picking and imputing, and the rest will generate the quantity that you needed. What am I trying to say? Let's say for this footing, which is a base type 1, if I want to measure the reinforcement for this footing and the starter column, the only information I need here, because this footing is a square footing, I only need one of this information, which is 1.5, and I needed the 350, which is the thickness of the footing. Then I needed the length from the bottom of the footing up to the top of the oversight concrete, which if you add 350, 850, 350, and a 200, you're going to get a 1.75. For the lapping, which is also referred as the starter, in this case, we are given, but we are going to take the worst case scenario, which is if we are not given this starter. We have a standard to apply, which is a 50 by the diameter of the bar, gives us what the length ought to be from the top to the starter, to the end of the starter. So we have this information as 1.75. We have the thickness of the footing as 350. We have the footing length as 1.5 by 1.5. But during the course of this teaching, I am also going to show us how, if the footing is a rectangular footing, how to go about it. Because in this case, I'm only taking this dimension, but if it's a rectangular footing, I need the 2 dimension to carry out my measurement. So let's assume here is a 2 meter by 1.5. Let's have that in mind too. When we go to my spreadsheet, we are going to apply that. So the next information we need to complete what I needed to compute my quantities is the cover. We can see from the general note, I have a foundation as 50 and the column as 40 cover. So having gotten this information, we will go to the spreadsheet now and apply it. As you can see, I have my bar. What I did here is this area I'm going to impute the 1 meter 500, which is the length of the bar, length of the footing. Then I'm going to impute cover. I'm deducting cover of 50 both ways, making 100. And so my effective length now would be a 1.4. Is a 1.4. Is a 1.4. Then a 1.4. I have to deduct bent, which is 2 times the diameter. The bar dia is 12 mm. That's why I have 12 mm here. I will highlight this as well. See if here too becomes if here becomes say I have here too, say the bar changes to 16. So I needed to change this information as well to 16, but in this case it is 12 mm dia. So then I needed to put the thickness of the column, thickness of the footing, which is 350. So as soon as I impute it here, I deduct cover of 50 by 2. That is, I'm taking cover from the top and the bottom. Then I'll be left with 250. Then 250 times 2, because I have one return here and I have one upward return here. So it becomes 500. 500 plus 450 or 1.4 minus 48. I am left with as my clear length for this bar is 1852. 1852. Then from the design, the spacing is 175 at centers, 175 centers. So I go back here, I impute 175 here. As soon as I impute 175 here, I have my total number of bar, which is 8 number plus 1, making 9. And because it is a square footing, the reinforcement running towards the other direction too is a 12 mm. So it is the same length of 1.8. So now I multiply by 2 the number, which you can see 9 multiplied by 2, I have 18. And because this information is already linked to my bar bending schedule, and we all know that the footing is a 2 number as indicated here. As indicated here, total number of footing is 2. Total number of bar in each is 18. Then the length of the bar is 1.852, which now I multiply the length, total length in each, total length times the number in each by the number of footing gives me the total linear meter of reinforcement. And it is in bar 12. So I am now linking the total length to bar 12 divided by 2 to convert it to by 1000 to convert it to meter. Then I go back to my column. I rightly said that the height from the bottom of the bottom of the footing to the top of the oversight concrete 1750. And the chair, the bottom chair for the spread that will spread the load to the whole of the foundation. If it is not given, like in this case, we are not given this length. The minimal we can allow take is 300. So because this is not given, we are going to insert 300 here. Then I did said we are going to take the worst case scenario. If we're not given the starter, we're going to put the diameter of the bar is 16. 16 by 50 gives us 800. So 800. Now I am deducting the cover at the bottom of the base, and I'm deducting the reinforcement running over each other. 12 mm, 12 mm gives me 24 mm. So that is why I have minus 2 times 24 times 12 give me 24 mm, since the diameter of the bar at the foundation, at the footing is 12 mm, gives me 24, plus the cover, the bottom cover, then I have 74, minus 74 from this two lengths, I have 2.77. The bar type as indicated is as indicated is 01 and is 4 number 16. So I have 01 bar mark, then type is 6, bar type is 16, number in each is 4. Then the length of one is 2.776, so approximately 2.78. So the stirrups are 350 by 150, and the bar type is iron 8. And the bar number as well is 01. So we go to, I have my 350, then I'm deducting bent, which is 8 mm dia bar. Then I'm lessing cover, which is we saw 40 in the saw 40. We have 40, then the other side is 150. We less cover, we deduct bend, we less cover. So the length of the two side is 276. Then multiply by 2 gives me 551. Then you're adding this return down, which is 50 times 2, 100. 100 plus 552 gives me 652. So now the area where the stirrups is going to be placed is not 1.7. It's a little lesser than 1.7. So we go to the drawings to determine where, as we can see, it's going to span from this location to this location. So you are going to add 850 plus 350 to give me 1.2. And now this is the bottom of there is a 50 gap from the bottom of the slab, yet the mark is not up to where the reinforcement is going to start, but we're going to take that and take out cover of 40 bottom, 40 top, so that the links will not be resting on the concrete, which is not bad because it is against concrete and concrete. But since it is not lapping at the bottom of this, let us as well apply the same principle, since that is what the the designer has said. So we go back to our whatever and put 200 here, which is the length. Then the length 200, and I'm taking out cover of 40. I'm taking out cover of 40, which is 2 times 40, that is minus 80. Minus 80. So now 1.1 meter 120 divided by 50 centers give me 7 number plus 1 gives me 8, and that is why we have 8 number as specified here. So having impute this 3 information plus this other 2 here, I'm done with the reinforcement for the starter bars. I come to the column, to the bar bending schedule. Already the footing is 2, so the information is here. The informations are already here, and they are all linked to this place. As you can see, for the stirrups is on the column of iron 8, while the main bar is on the column of 16. Then the next one is the super. Let's go to, we have the height from the oversight concrete, which is the ground floor, to the first floor as 3 meter 150, and we have a beam depth of 450. So these are just the 2 informations I need to get the length of this reinforcement. So what I'm going to do now is me taking this information is 4 bar is 16, is 4 bar is 16, and this is 3.15, 4 meter 450 depth beam. So I go to my information. I have 150, and this lapping is the lapping is 50 times the diameter gives me 800. Then yes, 50 times the diameter 800, because this is going to immediately rest on the existing ground floor slab, and the bar is 16. The numbers are 4, and this is the approximate length up to the lapping above. Then the column is still 350. I have my stirrups at 8 mm dia. I have my cover of 40. I have the other side as 150. I immediately impute this. Then, because my stirrups is not going all through to the end, it's going to stop. It's going to stop at the bottom of the upper beam. So let's go and determine. So meaning I am going to take this 450 off from my total length to get what my number of my stirrups will be. So what I did here is I took the length, which is a 315 minus 450. It gives me 2.7. 2.7 divided by 150 gives me 18. 18 plus 1 gives me 19. And if you come to my column bars, my upper column is already, the length is already shown here. The stirrups are already shown as well. You have it here. Then immediately I impute those information I just took. I have my total width in kg for the two footing, two starter columns, and a ground floor column. So you can see if I have, say, a 50 types of base, and I've already extracted, I have already counted them, and say it is properly counted. It is properly counted in this manner. It is properly counted in this manner where we have 2 number for this, 17 number for this. So I just pick this. So within the space of 15 minutes, I am done measuring everything that has to do with the reinforcement for the footing. I am also done with the measurement of this, because I'll just copy the first one, replicate it. Then if the column shape has changed, say it's a 500 by 150, I only change the links, and if the numbers of bar has changed, I change the number of the bar. I repeat it till I get to the end. So like I said, that should, in case you have say you have a footing of say the sizes are not the same both ways, we have a 2 meter by 1.5, meaning that it's a rectangular column, rectangular footing. So what I needed to do is now have a 2 meter here. I have changed 2 meter here. Every other information remained the same. The only place now I needed to now interchange is the number in each. I am now going to pick this, the above one, and I am taking this one. So now the number in each along the 1.5 axis is 11 number. 11 number, while along the 2 meter axis is 9 number. Then if the bars are, say is a double matted footing, say it's a double matted footing, and it's both ways, so meaning that this one now will be by 2 by 2 by 2. So I'll now multiply this again by 2. Then the same thing I'm going to do in this direction if this one too has a double. So I am multiplying this one by 2 by 2. So I come to the formula, multiply by 2. So I have 36. So now I have 36 here. So what I don't needed to do now is to create another let's say I am now taking this one is a 135. I am now taking the 2 meters. I'm now taking the 2 meter. I'm taking the 2 meter. So I have 2 numbers. I now go. I am taking no, I am taking, yes, this Where's the 2 meter? I am taking the 2 meter. I'm taking 36. So it will now be B1 because it's both ways times 2 times 2. So I have this. So you can always modify your sheet to reflect what the drawing you are working on is demanding from you. So you can see that with this, I've been able to show us how we can prepare formats in Excel that will aid us to fast track our job and make our job easy to correct. Let's say you are a contractor, quantity surveyor, and it's demanded of you that at every end of the month you submit your measurement sheet and your bill for checking. So you can see if you send this to the consultant quantity surveyor, he goes through, probably he finds areas where you've not actually done properly. What you don't need to do is just to highlight it and send it back with a note that you should check those places he has highlighted that something is wrong. And if you have checked and there's nothing wrong, what you needed to do is to go to see him and explain to him the reason behind the way you completed your whatever. And if he's convinced, he will allow go. But if you are actually wrong, once you correct it, immediately you correct it, it will reflect on your bar bending schedule, and automatically this will correct itself. So you can see why it is good that we employ the use of Excel in our measurement. If I've been able to expose us or shown us another angle towards the use of Excel to take off reinforcement, please leave a comment on my page, share the video, let it go around. And also, if you are watching my video for the very first time, please subscribe to my channel. And if you are yet to subscribe and you've been a follower of my page, please subscribe to keep us encouraged to keep on exploiting more areas that will help us reduce the workload that we do as quantity surveyor. Thank you. See you in the next episode.